AISC network webinar. I'm Yung Wei, the moderator for today's session. So this fireside chat is funded by the Royal Academy of Engineering, UK, under the Frontiers Champion. So can city tackles urban issues using machine learning? Today we are going to hear from two distinguished guests who are going to share their views on this matter. So before I introduce the panelists, there are actually several housekeeping items that I would like to highlight. So this session will be recorded and will be made available in our YouTube channel in a week's time. The certificate of participation will be provided to attendees who submit their feedback form at the end of the session. So do remember to submit that if you want the certificate of participation. And if you have any questions that you would like to ask the panelists, you can use the Q&A box that is available at the right side of your panel. Yeah, so I'm going to introduce our panelists. We have Wee Hyung Talk from Microsoft joining us from Seattle. So he is Group Product Manager and part of the Cloud and AI organization at Microsoft. He has extensive leadership experience and leading global and multidisciplinary team of product managers, engineers, and also data scientists. He works in cutting-edge data and AI capabilities, and in his career at Microsoft has worn many hats, from developer, product manager, data scientist, researchers, and also strategists. The rich career experience have given him unique superpower to solve some of the world's most complex technology problems. From taking a product from early incubations to shipping, driving product strategy, innovation, and building new engineering and data science teams in new geographical locations, Wee Hyung has built up a proven track record of simply making things happen and delivering impacts. He's a tech visionary with a unique background that span across product management, AI, and working on complex engagement with customers. Prior to his current role, Wee Hyung was head of AI Labs, where he led a global team of data scientists to deliver cutting-edge ML AI solutions from customers spanning different industries. Wee Hyung had a PhD in computer science from NUS. He has co-authored more than 10 books on product and AI, including practical automated machine learning, deep learning on Azure, and predictive analytics using Azure Machine Learning, and more. We also have William Lee joining us from Singapore. William is Deputy Director at SIA NUS Digital Aviation Corporate Lab. He is involved in strategic innovation, policy, planning, and management by bringing disruptive technology to market, to venture creation and new business with intelligent machines through digitalization and digital transformation. He has experience in both corporate R&D and academic, having worked in Panasonic and HP before joining NUS. Yeah, so I do have questions for Wee Hyung. Can you share how cities can utilize the power of AI to tackle urban problems using the technology from AI, ML, and also the cloud?
I think today, if you look at the progress of AI has been moving extremely fast, right, at an extremely fast pace, whether it's in computer vision, whether it's in natural language processing, or even fundamental algorithms. And the ability to fuse data from all the kind of data sources across an urban setting and be able to then leverage it in order to, empower both data scientists and engineers, right, to build very practical solutions to solve some of these urban challenges. I think it's no longer science fiction, right? It's very true today. And later on in the talk, you will see some of these conversations around some of the work that my team or folks across Microsoft or even in Southeast Asia has been doing in order to use AI to solve some of these challenges. And hopefully that will help the group here.
Okay. Yeah, maybe you can share from your presentation how Microsoft have been helping the cities and also the industry in using the AI.
Sounds good. So should I start sharing my screen? Okay, tell me when you can see it.
Yes, we can see.
Sure. So I have about 20 minutes, right? And let me just start the stopwatch, so I make sure that I do not exceed my time. So I think today we see very passionate technologies, right, from different walks of life in society who are using AI and machine learning to tackle some of our toughest society, environmental, and urban challenges. And like before we get into the specifics of the technology and so on and so forth, I felt like the successful application of AI is to put people at the center of all the kind of innovations that we do, and put people at the center of how we go about solving these challenges. Because I think the potential of AI combined with all the ideas and people definitely has a huge transformative power to leave a positive impact, not just I think in Southeast Asia, but the world as well. And so the way I structured my presentation is really on three pieces. One is the pace of machine learning innovations, and if we're not gotten up to speed with it, it's good to take a breath on wow, things are moving at a pace faster than we can ever imagine. And I'll share some of the work that my team.
Can you speak a bit louder? I think
Oh, sure.
sorry
Can you hear
about
me now? Can you hear me better?
yes.
Sure. And I think the other piece that I'll cover is really on the use of AI in some of these urban challenges. Not exactly all urban challenges, but more specifically, work that my team and folks across the whole of Microsoft has been doing over the past many years in order to tackle some of these really fun challenges, if you will. And then I'll end off with some of the commercial purposes, but AI is really relevant to leveraging it for the greater good. And I'll share with you some of the programs that we have at Microsoft. So let's start off with the pace of machine learning innovation. Now, if you look at it, if you look at for example, 2018, right? Somehow something happened. Can y'all still hear me? Yeah. So if you look at, for example, 2018, right? Today you have tremendous kind of progress made in NLP. And even in 2018, you have about, this notion of a transformer or transformer ensemble, which is commonly used in natural language processing, which of course you see incredible advancement, whether it is in areas like speech recognition, translation, image classification, and so on and so forth. Now, I'm showing this slides not just to capture, the kind of achievements that we've made together as a community, but to show you the progress of, from 2018 to 2019 to even 2020 today. The power of AI models is not just increasing, but AI models are also getting larger to a point when today, it's not just talking about millions of parameters for a model. We're talking about billions of parameters for a model, right? And if you look at it, the innovations of AI is really centered in three things. One, which is in algorithms. Algorithms has been improving at an amazing pace. But at the same time, hardware has been improving at a crazy pace, right? This slide I did not update with what was just showcased last week at the Tesla AI conference, when the ability to pack a huge amount of compute power into a chip and be able to cool it and be able to extend this in a linear manner has been just crazy, right? And last week at the Tesla AI World, you have seen some of the transformative AI work that even Tesla has been doing in the context of the self-driving car. And I think there's also tremendous progress made in infrastructure, right? Whether it is a laptop that we're using today, GPUs are everywhere. Whether it is being able to do inference at the edge where there's less compute. Today, that is readily available to many of us. And of course, you have the power of the cloud, right? From many of the huge cloud vendors, Microsoft included. But more importantly, what is also happening is, I felt like whether we are an AI practitioner or we're not an AI practitioner, today with the availability of a lot of pre-built models, we are able to do AI. And in fact, if you look at a lot of the kind of discussion that's happening in the community space today. A 14-year-old, with looking at self-learn by doing learning from videos that's available on the internet, is able to build a model that's able to address a very critical problem on, retinopathy, and so on and so forth. And at the same time, there's tremendous kind of tools and resources available for us to custom the models. And so innovations in algorithms, hardware, and infrastructure has indeed accelerated the pace of AI. Now, many times in many of the conferences that I do, ask people how long does it take to train a deep neural net? And of course, we'll say, well, a deep neural net this question is not a good data science question because it's not specific. But the real specific question is, how long does it take to train a ResNet 50, which is essentially an CNN architecture that's commonly used today, on a data set called ImageNet? Now, it turns out that over the past, and this is even data that is not up to 2021, from 2017 to 2019, the time taken to train a net has gone from days to hours to minutes. And of course, you could argue that, well, this is trained on a huge amount of hardware that's available. Can all of us do it, right, in the context of the organization that we're in and so on and so forth? And it turns out that you can. Right, today, for example, what you see here is some of the results from a benchmark called the Dawn benchmark. And Situ Choksi is a very active AI practitioner in Singapore who just joined Microsoft earlier this year. But at the point in time, he was just playing around with the cloud. He said, well, I do not just want to use all these pre-trained models. I want to train it from scratch. And see, he took only about $21 to train ResNet 50 on ImageNet from scratch. Right, and in fact, it only took the whole training time took only less than 2 hours. So the point I'm trying to get to is not whether C2 did an amazing job, etc. Of course, he did an amazing job. Is that today all of us can do it. We have tremendous amount of power available at our fingertip to do this right at an amazing cost. Now, if you go to another angle, look at how a language model has evolved over the years, and this shows you from April 2018 to 2019. At that point in time, the NVIDIA Megatron model with 8 billion parameters, you say, well, it's large. Now, you fast forward several even months later, right? Microsoft with the Turing natural language model at 17 billion parameters, we think it's large. And that was February 2020. Now, if you fast forward again, May 2020, we achieved a 10 times increase in the number of parameters in a model, trained at 1/10 the speed. Which is just amazing. Now, you think this is great. Now, you fast forward again, OpenAI in July 2020, and that's 2 months different, has a 175 billion parameter model. Now, you fast forward again to earlier this year, Google with its Switch Transformer is trillions of parameter. And of course, I think, you get where I'm getting to is that the pace is just crazy. And more importantly, this is not just pace that's available to all these big tech companies in the world. Many organizations today have access to all these models that has been trained for us to do amazing work. And so with that, I'm going to share several work that we have done over the past few years in order to show you what we have been doing. One is, in fact, this is work that was done many years ago. And at that point in time, what has happened was that one of these data scientists, or I'll say that person that was curious about data filed a request in the US. And like in the US, you could request for information from the federal government. And this request was essentially, he filed a FOILA, right, which is the Freedom of Information Act request, to say, I want data from all the taxis that's operating in New York City. Now, he think it was not possible to get it. A few weeks later, someone contacted him and said, hey, well, we have this data, it's on the hard disk. Can you just come down to this place to pick it up? He thought it was a scam. It turns out that they really prepared the data for him, which is several gigabytes. And of course, after he got the data, he made it available open source to the community. Now, the data set was about 1.1 billion taxi trips, covering January 2009 all the way to June 2015. It contained, for example, the precise latitude and longitude information, date time when the trip started, what payment method was used, was it cash, was it credit card, how much was the fare amount, and what was the distance traveled. Now, this was the first time the public taxi data was released by this FOILA request from a guy called Chris Wong. And all this data are supposedly anonymized data. And so you could only get to, all the trips, what were all the stop location and so on and so forth. But this allows you to get a pulse of the city, right? It can use to determine where people live, where people work, where people socialize in the evening. And it allows people to even understand very deep insights. Like people even use the data to understand where all the celebrities are staying. Not exactly the right thing to do. And whether they're paying tips to the taxi drivers through all this data. But I think the point that we're trying to get to is people have fun with the data and you get amazing insights. So what you see here are two maps that data scientists in the community has done on New York taxi pickups and drop-off between that period. And it shows every single taxi pickup and drop-off. And it's made up of many tiny dots, where the brighter region indicate more taxi activity. The green tinted region represent activity by what they call the green borough taxi, which can only pick up passengers in upper Manhattan and the outer boroughs. And this gives you deep insights into the pulse of a city, but more importantly, allows you to plan some of the public infrastructure that's available. Now, it turns out that while this is happening and people are having fun with this data, this is also happening in Asia as well. At that point in time, I was based in Shanghai. And around the 2008, 2010 period, right, there was also the World Expo. And as a result of the World Expo, it has led to a lot of the taxis in these cities, right, being equipped with boxes with GPS chips in it, right, that's continuously streaming data. And it turns out that you could get a pulse of the city, whether this is a vibrant city, whether this city, which are the areas that really need attention to through all this pulse of data. And of course, it turns out that this data becomes really sensitive, right, because it could disclose things that are not necessary there. And it turns out that, there was one researcher, and this is a guy that I used to work with before he left Microsoft, Zheng Yu, from the Microsoft Research Asia. He led an area called urban computing. And he was a very visionary guy that looked at how do you fuse data from the infrastructure, the network itself, from all these taxi traces that are available, the public commute, from a human mobility perspective, and even where are all the zones for the business areas. And if you could fuse this together, you could power many urban applications, whether it's the ranking of real estates, planning where you should situate a mall, and so on and so forth. Now, it turns out that this is not just done in New York City through the New York taxi example that I showed you. It's not done just in Shanghai, Beijing, in many parts of the world, because today a lot of these rental cars are already equipped with this kind of GPS, LED and log, and many rich information. Many people have started looking at how to fuse this information to get tremendous amount of insight. Right. I'll fast forward a bit so that we can cover all the content. Now, the other area I wanted to cover is this whole notion of precision conservation. And this was really joint work that we did several years ago with ESRI, or ESRI, who is the map company, and also a group called the Chesapeake Bay Conservancy. And it turns out that this was actually a really fun machine learning problem. This was a land cover mapping problem to the subject matter expert, but to us, it was a pixel coloring problem. And it turns out that Chesapeake Bay, which is one small part of the US, they rely on manually created high-resolution land cover map for precision conservation. It was about 100 miles of an area which they call a watershed that they wanted to map. 2 terabytes of data. It took them, experts, 18 months to create the map. Now, the fun part of this is that by the time they created the land cover mapping in December 2016, it was already out of date because it was too time intensive and it was too costly. And so this was the problem when they came to us, that they say, hey, can we work together to solve this? And it turns out that you can. So the challenge was, how can you use machine learning to create high quality land cover map with today's high resolution imagery? Now, the fun part of this is today's satellite imagery is no longer just available to, very specialized organization. All of us as consumer can leverage on commercial satellite imagery that many startups are providing globally. And turns out that all these commercial satellite imagery, of course, has different kind of qualities and so on and so forth. You are not able to use AI or machine learning to be able to understand whether this was a piece of land, whether it was vegetation, whether this was a road, whether this was a water area, and so on and so forth. And so we did partner with the Chesapeake Bay Conservancy to build an AI system for generating 1 meter resolution land cover map. And not only did we apply in Chesapeake Bay Conservancy, we took the same AI model and applied to the whole of the US. And in almost less than a few tens of minutes, we're able to, take all the satellite imagery, go through the algorithm and color every single pixel to say whether this is, land, whether this is vegetation, whether this is water, and so on and so forth, which is a fascinating piece of work. Now, I'll show you a video, and I think we should have time for the video. Let me just play the video.
I've been a waterman on the Chesapeake Bay since 1995. When you're out there on the water every day for that long, you see how things have changed. It's hard knowing there's nothing you can do but watch.
My name is Bob Ingersoll, and I'm a farmer. The demand for our kind of work is only going up, and we're constantly looking at how to expand our yield without stripping the land or polluting the bay.
The Chesapeake Conservancy has been focused on creating tools that help answer some of these questions.
In the infancy of the Chesapeake Bay program, scientists built a scale physical model of the bay to understand how processes worked and to simulate potential solutions. A lot has changed since then, and technology has been the catalyst. The Chesapeake Conservancy has been a pioneer in the field of precision conservation, getting the right practices in the right places, but it hasn't always been easy. Until recently, land cover data was only available at 30 meters resolution and represented what the landscape looked like 7 years ago. Not great for precision planning. We raised the support and spent 18 months working with our partners to create a 1 meter land cover database for the Chesapeake Bay program. This unprecedented project took a lot of effort and massive computing power. Now we are working with Microsoft and using AI and deep learning to accelerate our work both in the Chesapeake and across the country. Our collaboration is aimed at providing partners with the information they need to make informed decisions.
So I think what you saw earlier was just essentially the work that we did in land cover mapping. And with the Chesapeake Bay Conservancy, right, we have been able to achieve tremendous amount of work, right? Now, this just give you a quick idea of where the Chesapeake Bay watershed is. And this just shows you the satellite imagery of what it is. And if you look at the next slide, right, this just shows you, what we call the NAIP imagery. Now, NAIP imagery is actually 4 bands, right? It's RGB and near infrared. What you see in the center is essentially the label. And what you see on the right is essentially the output produced by the machine learning algorithms. And of course, our results at a point in time, and this was like 3 years ago, our results today is even much better than this. After 1 epoch of training to 250 epoch training, we get really amazing amount of details to color every single pixel of the map. And if you look at it, well, this is applied to precision conservation related kind of work, right? This is also very relevant in a lot of the kind of urban planning work that we are doing in many organizations, by many organizations today, right? And we, not only that, what you see on the lower right hand corner, we took this and we built it into the Esri tool as what we call raster function, that now when you use the Esri tool for planning, you could also leverage the AI models as well, right? Now, the other project I want to quickly share is essentially FarmBits. And what is FarmBits is essentially a project that was started by a Microsoft researcher called Ramveer Chandra. And he was motivated by one problem, which is by 2050, the demand for food is expected to outpace the production by over 70%. And so the goal of the project at that point was farmers need access to better data in order to maximize the efficiency and yield of the land that they have. And again, this was a project that we did, the challenge was how do we solve it using machine learning and be able to understand which part of the land is fertile, which part of the land is not. Now, I'm not going to show the video due to a time constraint. I'll share the video later. But the key crux of this technology is several pieces. One is in a lot of these rural areas, if you will, internet connectivity is a problem. And so we, at that point in time, Microsoft Research invented a technology called white space, which allows you to overlay Wi-Fi on a huge set of, I'll say, reach, if you will, that then allows you to be able to communicate all this sensors data back to the farm, which has the necessary compute to push it to the cloud. Right. So this was the deployment that was done somewhere in upstate New York and also in Washington State as well. And these are the kind of devices that we deploy. And we also put hot air balloons with drones and cameras on top. And you actually see really fun things, right? Water puddle, cow dung, cow herds, stray cow, and so on and so forth. And we use this again to build a panoramic view of the land that we could overlay fertility information. Now, due to time constraint, I'll quickly get to AI for Good. Now, these are some of the AI for Good programs that I was also part of several years ago, which is how do you use AI for good. The first one, which is what I showed you earlier with Chesapeake Bay and Esri, was really part of the AI for Earth program, with a goal today on taking a lot of the land cover mapping work that we have and creating what we call a planetary computer, where we can plug and fuse all this data from all these data sources and non-profit organizations in the world, be able to create a 3D map, or rather a 2D map that is rich with contextual information. And today, we provide about 230 and more grants across the various countries in the world, and we continue to fund a lot of the non-profit work in order to use AI, right, to solve some of this tougher sustainability challenge. Now, AI for health, with COVID that's happening, we've been spending a lot of work working, again, a lot of non-profit healthcare organizations on how to use machine learning to solve some of these health issues. AI for accessibility, helping, whether it is the visually impaired navigate the real world, to being able to help folks to make, the tools that they use and the software that they use more accessible. AI for humanitarian action, we've been doing a lot of work in the area, from helping kids in villages that has cleft lips, being able to predict the success of the operation, to many others, and we continue to make significant progress there. Now, the most recent one was AI for cultural heritage, which is how to use machine learning to be able to preserve the cultural heritage of very rich cultures around the world. And of course, I'll end off with, this is one of our vision on creating this notion of the planetary computer. And the goal there is to be able to interconnect all this environmental data and provide tools that's available to researchers as well as non-profit organizations to understand the world better. And hopefully that will help us solve some of these urban challenges that we have today. So thank you for your time, and hopefully this is useful to the group.
Thanks, yeah, great sharing. Just a question. So basically, you shared how model pace is expanding almost like exponentially. But maybe in the in some countries, for example, in developing countries or in some local governments, the infrastructure may not be expanding as fast as the model itself. So what's your thought on this?
I think there's several parts of it. One is, I think the training of these large models, it's true that being able to train these huge models still remain the reach of a lot of the big, whether it's the tech companies or the research institutions in the world, who has access to tremendous amount of compute resource. But the fun part is, these models, after they are trained, right, the models itself, or the pre-trained models, if you will, now is readily available to all of us, right? So for example, in the space of NLP, you could now access all these models that's been trained by all this huge amount of machinery, right? And being able to leverage it in your code by just downloading it and using the model Zoo from Hugging Face, right? And so while we don't have the compute to train all this model, we now have models hardware that can leverage the output of this model, which is fascinating. So I think even with that, you can already achieve amazing amount of work leveraging just pre-trained models, right?
Okay, thanks. Yeah. So there is one question from the attendees: how you solve the problem of mass tourism using AI for cultural heritage? When tourism is the main activity that represents 70% revenue of the sustainability of families in Thailand or Highlands.
I see. Sorry, can you repeat the question again?
So the question from the panel, one of the attendees, is how you solve problem of mass tourism using AI for cultural heritage. Yeah.
I think when the AI for Cultural Heritage program started, some of the early problems that we solved was language, right? The ability for us to break the language barrier and being able to enable anyone to communicate with each other. I think that's the first piece of it. And so we, like in the past, in order for you to do translation, again, you need huge amount of compute. Today, that's not true anymore, right? And you also need tremendous amount of data, which is the source target pair for you to do translation. Now, today we're shown in some of the work that we did in AI for Cultural Heritage that even with very little source target pair, one, we can do translation. Of course, it's still not perfect, but now it allows people to communicate. I think that's one piece. Two is, I think today, there's been tremendous of work done in recommendation systems. And like from a tourism perspective, being able to understand what is everyone's click behavior, which are the things that you like, which are the things that you do not like, right? And then be able to make very precise recommendation to say, hey, you might want to consider these areas in Thailand, and so on and so forth. That's, I think, already starting to build in a lot of this kind of sites, right? Like in China, there's Ctrips, which I use a lot when I was based in Shanghai. In the US, you have Expedia and all this, which has started to use all this as a way to not only just package really specialized itinerary for people to visit a place like Thailand, but at the same time be able to make it really, it helps you discover information. And I think we're all suffering from an information overload problem. And so if we solve the language piece to allow people to communicate, help people to discover, that might also be, hopefully that answers the question, right, in a very broad way. Yeah.
Okay, thanks. Yeah, we do still have some questions from the attendees, but I will hold on to that first. So I have questions for William, and you do a lot on research in AI, robotics, machine learning, autonomous systems. So can you share how this technology has changed from the area of digitization to digitalizations and also the digital transformation?
Yeah, I'll go to a slide mode and I'll try to kind of run through. So I guess a lot of stuff for mine is really on the robotics part. So I think Wee Hong has put a part of AI. I come just also to add on my joint appointment besides SIA and US Digital Aviation Lab. I'm also the Associate Director for Advanced Robotics Center. I got a part-time teaching assignment as a adjunct professor. And the role of what we do is more than digital. It's more than AI. It's actually to the machine and devices. So your question comes about, well, this probably already mentioned before. So I think neural networks has been around. So these are some of the works that we've done. In fact, close to 10 years ago, our recognitions from a matrix standpoint, when you're 1.0 is actually close to 100%, 0.9 is 90%. You can recognize all this. So neural network has been done from a vision standpoint very well. So not only at the everywhere else. So from a sensor hardware standpoint, not only cameras, we got LiDAR, we got radar. So you can see the green dots is actually a LiDAR information. The orange dots is actually radar information. Of course, you can see the picture that it is. So all this data, more than just pictures, there's a lot of that out there being acquired by various advances in sensory. So when a city network it comes along, But I really want to put up a bit about my emphasis. Let me go to very quick. NVIDIA, we work very closely with them. It's actually how we believe autonomous technology comes along. This is actually with a project joint lab with our Because Smart. It's actually the Singapore MIT Alliance for Research and Technology. I like to show this particular vision, which actually we did it close to 7 years ago. So this is an important concept that we actually proved it, well, 7 years ago. So you could see what is happening at Waymo and all this stuff coming in. Autonomous vehicle is possible. The demonstration of this particular concept, which was done 7 years ago, is about how a city landscape will come along, where you will have internal walkway transport. They're going to be a buggy, wheelchair. So you put on a road transport. So today, from a technology standpoint, as what again Wee Hong has put along, compute has come along. So all this stuff is able to make the car very intelligent. And with the ability of pulling data, traffic data, all this stuff is able to make the next generation of cities as much integrated as possible. Literally as much as it is. You call it from a cab. The cab doesn't even need to be downstairs. It's probably just down your walkway and a transport from a pedestrian vehicle all the way to what we have, even a wheelchair, which we have to come along to bring all the way to destination. So robotics has come to a point that it works very closely with intelligence, AI. And that part AI will run through an entire amount of data. And from there, it makes sense of the environment and bring you there. This is tremendous that in the world of what is going to be the next 5-10 years, whether it's going to be a multi-sitting buggy strolling in the park, running through a city in a single autonomous wheelchair, which actually I do have to show. We actually really much there. It is. So in some sense, AI alone will not be able to do it. In the past, industrial robots would not be able to do it. When these two things come together, the world of sustainable city is possible, which how we will view as the future. That's a bit of sharing I'm coming at.
Okay, thanks, William. It's very interesting video that you shared just now. So just a question. Some people a little bit more skeptical to worry that is it safe or not? You know, when everything goes like in through the automation, through the internet, some people may be a bit skeptical. So what's your thought on that? On the safety and also whether people will hack or not, you know?
Yeah, those questions are very valid and will continue to be valid. It's not yesterday it came along and tomorrow it comes along. Put in context. Intel was founded in 1968. Microsoft 1975. And in those days, when I was much younger, I see a blue screen, the first finger at it is Bill Gates. What the heck? Now, for the last 40, 50 years, as much Intel is already 54 years old, we continue to evolve technology. The question it's not of today alone. Computers break down, blue screen, hang, those are questions. So as we go along sophistication of technology, it's valid. We will, as the industry progresses, we'll continue to deal with all those, be it the antivirus, cybersecurity, those will continue. So the question of that worry is not today alone. It has always been, but the magnitude has come along that, well, you have a bit of blue screen on a PC, fine. But you could imagine if that autonomous vehicle, blue screen and is going 100 kilometers per hour, what will happen? Now, I mean, giving a sense of context, the PC has been evolving through what is the workstation and even IBM mainframe for the last 100 years. 100 years. Give it a bit of time. The industry is working on it. So you can start to see that the concept that we prove along, whether it's going to be wheelchair, autonomous buggy, they're moving at quite a low speed. Give it time. As all those start to get better, compute gets better, sensors get more robust, data get more clear, AI get more intelligent, able to differentiate. All those problems will be in the past as we move towards the future. Give it time. In honesty today, there are some news coming from California trying to collect fees and running through, I think Waymo and also some other companies out there. But in a large scale, the world has not really implemented autonomous on a commercial yet. So again, the PC has been selling for the last 40, 50 years. Give it a bit of time, give it 5 years. I'm quite sure as we learn through it, it is. But I also want to put in context. Today you buy the latest car, whether it's going to be Honda, Toyota, they are already at what we call from a definition autonomy 1 to 5. They are reaching to 2, level 2. In the past, it was just blind spot signals, reverse camera cameras. But today you're talking about self-centering, auto braking for you. They are actually classification autonomy at level 2. So as we start the question, in fact, we are buying cars that actually can do autonomous braking today. So Waymo goes all the way at level 4, level 5, with this fully no steering wheel and all those types that it is. It will. It's a very visionary goal, very disruptive, will take time. But as you look from a sustained innovation standpoint, autonomy is available today as we buy new cars. So those questions are probably we want to even channel it to Toyota and Honda, how they came out with Honda Sense and Toyota Safety Sense. But again, the industry has not been invented today or tomorrow or going to be invented. virus scans and cybersecurity has always been around. So put in context, we have started a long time. The base is not at zero. It's been somewhere there. But as we go along introducing more autonomy, I'm quite sure the community and research will actually advance robustly. So in the long and short, we are not at zero. We have been building a long time.
Yeah, thanks, Peter. Just another question. Throughout your work, right? Do you think the collaboration between business stakeholder and also the governments are important when you want to leverage AI in creating new values for the city?
Tremendous. I think what Wei-Hong has demonstrated, somebody just go drop into New York State municipal office and get some data from taxi. But one thing good about Singapore, actually all these data are available, released by our Land Transport Authority. Anybody will be keen to run through how especially the multi-mode transport has come along is possible. The question is really about who would like to take the challenge, or even at the policy level, want to think beyond just Uber or Lyft or Grab. Today, they are still thinking in their context of just point to point. But the visionary thinking we have always been proven from the video that it is. There is a possibility of multimodal at the very holistic level, not only at that section. End to end is possible. And today, from the compute, from the data, from technology, from autonomy, all are possible. The question is, who will be willing to put upon that very 38,000 feet higher than helicopter view that this city can achieve a lot of productivity from autonomy? You could imagine today, if I just say, after this conference, I just press a button out the door, something is waiting for me. I'll go to the next place in the next 20 minutes. I don't even need to park the car. I drop off. I'm having probably early lunch with somebody else, and after they come back. And the vision of what transport is no longer the drive. It's making sure that the key ingredient is the event itself, which we meet people. People is the most important thing. After a while, the car is something to facilitate that process. So I like to even challenge everybody to think beyond what is Uber and Grab. But today, technology can give at the highest level how a city can be so small, can be so short. We put all the intelligent machines helping us behind.
Okay, thanks, William. Okay, going back to a question from the participants on the things that Wei-Hong shared on FarmBeat. The question is, can you explain a bit from your presentation on the sensor integration in gathering the data? Yeah, I saw you shared in the chat the slides, but maybe if you can briefly go through.
Yeah, so FarmBeat's input consists of several parts, right? It has so one of the challenges that FarmBeat was trying to address was that today for you to deploy sensors in a farm is extremely expensive, right? And the bulk of the cost is actually in communication and getting the communication ready to be able to figure out where and when you have acres and acres of land, where should you be putting the sensors? So what FarmBeat strive to do is all these are readily available cheap sensors. So it has things like temperature, precipitation, and a whole bunch of other stuff. And also off-the-shelf cameras that's available. And what the FarmBeat algorithms allows you to do is it helps you figure out what's the right placement of these sensors strategically in the whole farmland that you have. But then it augment and complement this with the video footages from drones. So the earlier drones that we used were all DJI drones, which flies across the farmland and using the sensors or cameras that's including infrared cameras to be able to map out the entire land. Now the beauty of the whole FarmBeat setup is that with all these local sensors that's on the ground, where you don't require a lot, it is fused together with the drone imagery to form the fertility map of the entire land. And that allows people to plan, where to plant, how to plant, what to plant, when to plant, and so on and so forth, right? In fact, if you go online and search for FarmBits, FarmBits was also deployed in some parts of India as well, and helping some of the India groundnut farmer. It actually showed that it improved the yield of the groundnut if they use FarmBits to inform them when they should be preparing the land, how should they be preparing the land, which part of the land they should prepare. It increased the groundnut yield by at least 30%, which is phenomenal. So yeah, FarmBits today is available as a product that folks can use in order to integrate all this fusion data together, and the platform itself will fuse the data to give you the kind of maps that's needed, right? Yeah.
I like to share this particular video. I like to add on top of it. After viewing to a video, I'll give an explanation on it. So just give me a moment. Okay, my point here is that, give me a moment. My point here is, this is what you've seen from a real time. As our vehicles go around doing mapping, this is actually by LiDAR. Every time you go through a path, you get more data. You got more information, more detail. And you can start to see even the map self-correcting from orientation standpoint. And this is actually the algorithms today available to help to enrich accurate maps or even resolution of wherever you are. Now, today, if you look at every single car out there, probably 5 out of 10 will have a webcam, right? So the ability of having crowdsourced information to build a map actually today is possible. How you're able to pick up those images, do 3D construction of wherever the cars are seeing each other. Instantly, when you have the car today, in a couple of hours, you can map the whole city as a 3D construction in that sense today. So data has come upon that sensors are expensive in the past, but if you look at it, we only need a couple of cameras, a camera on a car, and even today's iPhone, I think they are coming out a new one with even LiDAR on it. Put a laser on it, everything else, you can crowdsource and build the data. Data will continue to enrich, it continue to have refinement. That process is really happening today.
Okay, thanks, William and Lee. So just now, Lee, you mentioned on the cost, right? So basically, FarmBits, it can increase the yield by 30%. You mentioned that. But in a lot of times, even like in cities, like the governments will think, okay, what's the return of investment? Investing in all this technology, whether is it worth it or not? What's the point? What's your viewpoint from both of you?
Oh, William first.
I think I put on my point. Today, as if we continue to live what we live, we're already reaching 7 billion people. Maybe not in sparsely places like Africa or mega cities. Can we continue to increase cars? And how much time do we need to drive off a car park and go and find a car park when we reach there? In honesty, today, I think all of us, if you take a compute time standpoint, you probably spend half an hour. We have done that research. Half an hour to go get to your car, drive out the car park, go in, and probably even have to pay the whatever car park fees. Half an hour. If the trip itself, the drive is only 10 minutes, then you realize why are you spending so much many times of it? Now, why it's so important that all this come along? If you're able to automate the entire process, you have another half an hour for actual productive meet, brainstorming, collaboration that you really want to have face-to-face. And today, face-to-face is really a scarce opportunity. We are all doing all this Zoom thing and all this webpacks. It's so important that we will continue to be human. Human that's different from robot is because I will have to have a coffee with you, have a good discussion, and we have a business going on. Whether it's going to be Japanese way or drink beer at night, or we have coffee or tea, business is the way. So it's so important that machine is what replaces, but we also mindfully say that replace what it is, but still put humans in the center stage of how we come together.
Yeah, and I just want to add on, like, I think today machine learning and applications of machine learning is very real. And for some of the technologies in the audience as well, you also recall many years back there was also the big data started, and then big data use cases started being more available. But then again, it allows you to solve the analytics problem. And I think machine learning approaches is indeed making us more efficient and empowering us to achieve even more than what we can achieve otherwise. And so I think if you put that in the context of the ROI question, the ROI that you get out of it is tremendous. And so, like, whether it is from a food problem that truly, we have to, there's only scarce amount of land, to being more efficient, like in this autonomous kind of systems, right, that William is talking about. If machine learning algorithms can truly make us more efficient and allow us to spend the quality time, even not just on work, even with loved ones, I think the ROI is just tremendous, right?
Yeah, I do agree. Yeah, and a lot of times I think this ROI is not like we look at short term, but it's actually a mid-term or long-term perspective, right?
It's really a strategic thing point, because it's inevitable. It's inevitable that those through AI, through autonomy, will gain a lot of automation. So put our time into what we do best, is human interaction. And when through human interaction, you realize that more ideas, more team, more collaboration, more teamwork together creates a lot of synergy and productivity. And 1 + 1 is no longer 2, it's 3. Every time 2 or 3 guys sit together, there's tremendous amount of productivity there. And that productivity, if anybody would want to measure it, will give you more business. The ROI comes in more business, more profit. It's how you want to shift that repeatable task to how machine will decide for you, which is whether it's going to be a robot bringing you to somewhere, or picking out a coffee. Or it's not now. I really want my coffee to be now, because I'm going to be dozing off. So if the robot bring me a coffee, which is possible, I know we need adding the holy grail of today to talk to a robot is actually NLP. And it's no different from what we see in the movie, which is actually is possible today. Talking Iron Man talking to Jarvis, can you bring me coffee? Can you bring me something to drink? And the fellow will decide for you, because based on my profile, they are one coffee, black.
Okay, thanks. Okay, we have just a quick one. A last question from the attendees. How will cities leverage from existing data with AI private companies? Yeah, maybe here it talks about how cities, business stakeholders and local governments can actually work together to leverage AI.
I think what we have seen globally is that being able to fuse data, whether it's image, whether it's text, on all sorts of data, in the context of the different cities, is, as you know, like William was alluding to earlier, sometimes it's a policy challenge. But if people could perceive that by sharing even some of this anonymized data in a way that benefit the entire growth of the city, I think today there's already mechanism for sharing data, for anonymizing data, such that privacy is not infringed, but yet you still have quality data to advance the state of science or the state of some of the city applications, if you will. And I think being able to build that framework to both aggregate data, be able to share in a way that respect the whether it's the intellectual property or whether it is the political boundaries for each one of this, I think it's possible, right? And I think if everyone comes together and have that will to wanting to share, technologies is readily available for you to aggregate and share, right? And of course, if you look at the field, many conversations are happening to say, well, can we get all this data into a huge, gigantic data lake? And then you make sense out of it, right? So even this notion of making sense of data is turning out to be a term that like many of the companies in Singapore have started organizing conference on sense making or making sense of data and so on and so forth. So I think it's possible.
I would like to add is that the challenge from a policy standpoint is probably tremendous and most important. But at the ground level, we need to start to find a way to articulate this particular personal vision. Let me use an example. I think the washing machine is a fantastic one. Prior to washing machine being invented and prior after that, I don't think today with all of us having washing machine at home, any one of us will want to wash the clothes ourselves. Correct? That is what we should do. How could we use machine autonomy to do what like a washing machine? Today you say that I don't have a washing machine, I cannot survive. It is the same as a vacuum cleaner. Do you want to still use a broom to sweep the floor? Because the vacuum cleaner is available. But we are in the transient stage of that. But when we are able to use a washing machine, a vacuum cleaner, to explain that when you go to autonomy things, you really don't want to go back anymore. The question is that we have to tip it over that the ROI question will always be same scenario when the day the washing machine was introduced. The ROI would say, should I wash? Should I? But if you think in hindsight, they're going to be washing machine or vacuum cleaner. We don't think back. We see this evolution of self-driving, autonomy, machines or intelligence that does a lot of stuff automatically because of the ability for data, autonomy, and all the perceptions around. And let us do what we need to do. We just wear our clothes, just walk the floor, and have a good meeting and drink coffee.
Yeah, maybe just to add on to William, like some of the things he discussed inspired some thinking. It's just to put a very practical point to it. Like for example, here in the US, all my Ring security cameras at my place is connected to the neighborhood Ring network. Why do I do it? Because I might infringe some of my privacy. It's because then it forms a whole neighborhood kind of crime watch. Whether it was a bear that was trying to upset someone's garbage can, to a theft of a mail from a mailbox, to someone coming to your porch and picking up and being a porch pilot. Now the whole community, every day I get a Ring, I know what is happening in my neighborhood. So the reason why I'm able to I want to connect to it is because I also get feeds of this information. So it has to be mutual, and that would itself also encourage sharing as well, right? Yeah.
So there are a lot of frameworks now at the moment that we are also pioneering in what we call as mobility as a service. Again, coming from autonomous vehicle, there's tremendous amount of spin-off ideas from autonomous vehicles. Because autonomous vehicles has all the sensors on board, able to collect data from camera, vision, LiDAR, everything else. Insurance companies are very keen to tap on it. The next time around, when you involve in an accident, some other car somewhere were able to record it and tell that, is it your fault, not your fault? And the sensors on board were able to tell, are you speeding, not speeding? So in a sense that you see that is an infringement of privacy, that will continue to be. But let's put it in from an ROI standpoint. If the insurance company says that because you give us to look at your data, your insurance from $2,000 become $2. Well, that is instant ROI because I'm a safe driver, and because other people see I drive, I don't cut lane, and the information is somehow anonymized, but yet you authorize only an insurance company to see it, and the AI will able to scrum through all the vision that is pertaining to you, your car, and the AI says, yeah, for last 1 month, safety driver 5 stars, discount 90%, immediate ROI. So the ability to share data in a very crowded environment, their techniques, the architecture, whether it's going to be using blockchain and all this stuff, their ability to do who can see what they can see. I'm quite sure the ROI is already there today.
Okay, thanks. Yeah, very last question. I know I probably just thought that's the last question, but there's one more, which I think is quite important because we see these issues on resource and human capital of OTT. So this can, the question is, it differs from city to city. So what would be the human capital implication to adopt and advance AI or ML in urban planning and machine management? Maybe we want to start from here.
Oh, sure. I think Singapore is close to my heart, and so I keep track of everything that's happening in Singapore. And one thing I felt Singapore did really well is it started this effort called AI Singapore. And so I think for the past 2 or 3 years now, it has been training batches and batches of AI engineer paired up with commercial companies and even private entities to solve very interesting problem that's relevant to the Singapore society. And I think the model in which they have done it, not just to use models for the sake of using models, but making sure that the manpower is trained to be able to leverage the models, and then being able to, as they're training, they get paid, but at the same time, they are also solving practical problems for the society. I thought the Singapore AI Singapore model has been something that I track a lot very closely, and it's close to my heart that, folks like Lawrence from AI Singapore and his entire team, is kudos to them for getting it to where it is today. And so everyone, I think if you are looking at, a model that can combine training, skilling, all the way to, solving important problems specific to the cities they're in, definitely reach out to AI Singapore. And, Lawrence has been openly sharing this with the community as well.
Okay, thanks. William, you want to add on before we wrap up?
Well, universities and research labs has always been training people. So it's always been that part of it. And for the last 11 years since Advanced Robotics Center has been conceptualized and established, 11 years, the research has been done, and numerous of our PhDs, masters, even undergraduates. Just only 2 years ago, we have a robotics specialization for undergraduates. 50 students every year, 50 out of that 1,000 students. 3 of the top straight A's, they are taking robotics. And the robotics is not what we have mentioned as the industrial robotics. It's really the intelligent robotics, AI robotics. So our role will continue to train at the undergraduate level. So mid-career people can always come back to do a master's to continue training in this area, or if after a bachelor's you believe that you want to specialize deeply into research, PhD is possible. So we're cranking students on a on a very advanced standpoint, and NUS as the Asia #1, we are at the forefront. As I said, all this work we've been doing for many years, and we will continue to put that effort. And today, my joint appointment is going beyond the road. I'm going to the sky. So today we're talking about, I won't give you too much of what it is, but we're talking about next time that you're going to see a multi-mode. We include a flight, and now it's not only in Singapore. We're going to put you on a buggy, then to the car, to the plane, and the plane to the other side of somewhere around the globe. And the whole journey is going to end to end, and you just don't have to bother. Just get something on your suitcase, get a couple of something to wear, and you're there going to enjoy that breakfast on the other side of the coast. That is what autonomy is about. It is possible today. We're working towards that.
Thanks. Yeah. So just as a summary, basically, we need to train more people, definitely. And not only that, we may need people from different disciplines, multidisciplinary field to actually work together and also to address some of the concerns, whether how cities can tap on existing AI private companies. I think they do need to collaborate together. I think that's very, very important, because without collaboration in multidisciplinary fields, I think it's a very long challenge to actually implement or use AI to create more innovative technologies in solving the urban problems. Yeah. So thanks to the panelists. Thank you very much. Let me share a bit. And thank you to the attendees as well. We do hope that you fill up the feedback forms that is available. You can see here, and we will send the e-certificates to those who already fill in the feedback forms. Yeah, and this feedback form will be available for 30 minutes once the event ends. We do hope that you join us in our next events on 21st September. We do have another event as well. So if you are interested, do provide us your contact information in the registration links you can see here. And we will keep you posted on all the upcoming events, collaboration meetings, and also a policy dialogue that we are organizing in October. Yeah, so thank you very much. Thanks once again to our panelists, Wee Hong and also William, and thank you to other attendees, and see you in our next event. Yeah.
Thank you.
Thanks, and have a great